For centuries, researchers and philosophers alike have been fascinated. The first to photograph snowflakes was Wilson Bentley, a farmer from Vermont. Bentley became an obsessed photographer at the end of the 19th century because, as a child, he had heard a sentence that he couldn't forget. No one snowflake is like another. The Center for Snowflake Research is today in California, of all places, at the California Institute of Technology, where there's a physicist who searches for the order that governs the wondrous forms of snowflakes. Ken Librecht is currently the sole physicist able to produce snow crystals in a laboratory. All thought of cosmic energy is scoffed at in these rooms. Ken works quite arbitrarily and always somewhat casually.
Oh gosh, it just sort of came up one day. We were talking about science and things in general, having a beer, and with some students, and it came up, and I was basically just interested enough to start researching it, just to learn about it, and then I got very interested in it. I found the physics was interesting, and a lot of it was unknown, and it looked like one could learn a thing or two by doing some experiments.
The snow crystals are bred in an icebox. It soon became clear that they react to the tiniest differences in temperature and to particles of dust in the air too, and that they alter their shape accordingly. Librecht won't own to having noticed any memory or cosmic influences. Thus, the old question as to whether two flakes look alike answers itself in a profane way.
Well, similar shape you can find, it's sort of true that no two snow crystals that are alike, at least the complex ones that fall out of the sky, they're a little like people. They have a lot of little nooks and crannies, and the shape they're in depends on the path they've chosen to fall through the sky. And no two crystals take exactly the same path, and so no two crystals are exactly alike. They're like people.
So it's that simple. But what is the solution to the great puzzle? Will the whole excitement about the memory of water turn out to be a delusion in the end? Or will the laws of physics have to be rewritten? Both supporters and adversaries alike of these daring theses profess to possess clear-cut evidence and claim to have true science on their side. One might accuse these courageous discoverers and inventors throughout the world of boundless naivety, they who are not afraid to question nature's laws. But in its infinite and glorious variety, water itself points physicists and heretics alike down a common road. A road with a signpost: never give up. I'm quite sure that we're on the right track. When I started to work with Yuri, I sensed that it was right. I'd like to add that lots of people come to us who've worked out new technologies, who busy themselves with the physical effects of water. They come to us because they're turned away by traditional science, which is often afraid of them. However, fear is something that hampers the development of science. We investigate these claims and phenomena according to strict scientific laws. If we find conformities which can be proved beyond doubt, we don't hesitate to talk about them and inform the general public.
Sometimes persistence does pay off. If you have a scientific instinct that tells you that people are ignoring something, I think it would be quite wrong for me to say they shouldn't pursue it, because going against the common belief is a very exciting thing to do in science and can lead to dramatic new discoveries.
Bei der Wissenschaft heißt H2O und Schluss aus.
The scientists call it H2O, and that's it. That's the end of it. But there's a lot more to it than that. And I'm of the opinion that they should look into water more.
Da mehr ums Wasser kümmern sollten.